Kia ora whānau, welcome to another Walinga video on geometric reasoning. I'll be covering a couple of rules from angle properties of circles. So I'll be switching back between a sketchbook and this Word document here, so bear with me. First one, two radii within a circle form an isosceles triangle. Sorry, whānau, zooming in. Base angles in an isosceles triangle are equal. So it's kind of two rules there, but we've seen this one before. This angle here, this rule here, sorry. So let's have a look at a visual. So here we have two radius. If we join these two radiuses with a line like so, that was a very bad line. I'm just going to go for one swoop there. There we go. This is radius 1 and this is radius 2. Because we know that radius is the same length anywhere on this circle, this length and this length match. So therefore, if we've joined those 2 points at the circumference, at the side of the circle, we therefore have a triangle. And this triangle is isosceles. And we all know that the isosceles triangle, or the base angles of the isosceles triangle, are equal. So that's your first rule. Angles in iso triangle are equal. And that's because two radii can be identified. Cool. Next rule. The angle at the center is twice the angle at the circumference, or the angle at the circumference is half the angle at the center. So the circumference of a circle is basically the outside edge. If I were to grab my little thing here, just put it top of here, basically the circumference is this. That's the circumference, okay? Right, so the question says the angle at the center is twice the angle on the circumference. And we can do a little quick example of that. Basically, if this was 100 degrees, then this angle would have to equal 50 degrees. And the rule is angle, don't need to write angles. Angle at center is twice the angle, it's a 2, angle at circumference. Or you can write it another way and say angles at circumference is half the angle at center. Either way works. Alright, next rule. Rule number 3. Angles from the same arc are equal. So, if you look at this circle here, we all know what the circumference is. The arc of any circle is basically a portion of the circumference. So, I'm just going to show something to you. That arc there, and basically what I want to show you is that this is an arc, and we have these angles here apparently come from that arc. So how do we spot that? Well, basically we can say that this angle here, if we trace it back, following these two sides that it makes, it's actually from this arc. And if we trace this angle back, it's also from that same arc. Yeah. So that's how we do it. We trace these angles back all the way up to here, and they're actually from the same arc. So if this angle was, say, 60 sorry, doesn't look like 60 degrees, maybe let's say 50 degrees, and we call this angle y, then angle y must equal 50 degrees because angles on the same arc are equal. Next rule. The angle in a semicircle is a right angle, 90 degrees. So, as you can see here, we have a semicircle because this line here is a diameter. This is a diameter. It cuts the circle in half, goes through the center of the circle as well, the center of the circle being here. And so therefore we have a semicircle, and this angle in a semicircle, in this semicircle, this side of the semicircle, is a 90-degree angle. It's 90 degrees. And we call this rule angles in semicircle equal 90 degrees. Right, next rule. Let's have a look here. The angle in a semicircle, that's the rule number 4. Rule number 5. The angle between a tangent line and a radius is a right angle. So over here in our drawing, this line here is a tangent line. Yeah. A tangent line touches the circle basically at one point, and it's always a straight line. So for instance, if I'm to do another one, just over here, that is another tangent line. Yeah, you can have multiple tangent points really, and a tangent always touches the circle at one point. So at that point, where we have the radius from the center of the circle to the tangent line, there is a 90-degree angle. Right? So some facts. Tangent line touches the point of a circle touches only at one point of a circle, and the line that connects the radius, the angle that connects the radius and the tangent line is 90 degrees. So angle how does the rule go? Oh yeah, so it goes angle between tangent and radius equals 90 degrees. Sorry, I momentarily forgot again. Here we have a couple of questions we're going to do. Let's focus on this circle here. We have that's supposed to say 41 degrees. That's 41 degrees. And if we have to find angle A is equal to 41 degrees because angles on the same arc are equal. And why do I say that? Well, it's because if I highlight the arc for you, it would be easier. There we are. Basically, if you trace this angle all the way to the circumference, it'll end up there. Trace it back to the circumference, it'll end up there. And if you do angle A, trace it back, it comes from the same arc. So therefore A is also equal to 41. Angle B is equal to 82 degrees because angles at center is twice, that's times 2, angle at circumference. So B is equal to 82 degrees. Yeah. And let me highlight to you that B is in the center and this here is on the circumference. So yeah, the center is always twice the size as the angle of the circumference. Sweet. Let's try one more. Alright, here we're trying to identify the angle C, what size it is, and basically angle C would be half 96 degrees. Yeah, angle C is equal to 48 degrees because as you can see, 96 degrees is in the center and C is on the circumference. So it was the rule that we used before where angles in the center is twice the angle of the circumference, or the angle of the circumference is half the angle of the center. So we can use it this way. Angle at circumference is half the angle at center. Apologies for the really bad writing. Let's look at D, angle D, and this here is an older rule. Angles around a point, so angle D is equal to 264 degrees because angles around a point equal 360. And then we have this angle here, E, which is actually matching with that center angle. So again, keywords, you got an angle at the circumference, angle at the center, so therefore angle E must be 132, as it is half angle at circumference is half angle at center. And that's basically how you apply these rules. You'll have to remember parallel lines as well. Don't forget the previous rules you've learned: angles and parallel lines, angles around points, angles on lines, because they'll also be mixed in with this type of stuff as well. So hopefully this helped, Whānau. I'll see you guys in the next video.